Identifying pumps. All pumps have the same basic function, to move liquids through piping systems to where they're needed in the plant. However, different types of pumps are used in plants, and they're identified in different ways. Liquid. One way that a pump can be identified is by the liquid that it pumps. For example, this pump supplies feed water to a boiler, so it can be called a feed water pump or a boiler feed pump. Function. A pump can also be identified by its specific function in a process. For example, this pump creates a vacuum in a process, so it can be called a vacuum pump. Location. Another way that a pump can be identified is by its physical location. For example, these pumps are located at the point where liquid enters a process, so they can be called inlet pumps. Letters and numbers. Now, there are also other methods that can be used to identify pumps. For instance, some companies identify pumps using letter and number combinations on process flow charts. More than one name. It's also possible to use more than one name for the same pump. For instance, a feed pump that's located on the north side of a plant may be called a north feed pump. That name is actually based on two methods of identification, function and physical location. The thing to remember is to make sure that you're familiar with the methods your company uses to identify the pumps under your control. Common components. Pumps can vary greatly in several ways, but certain components are common to all pumps. For example, all pumps have an inlet, a casing, and an outlet. Inlet. During operation, liquid enters the pump through the inlet, located here. This side of the pump is also called the suction side. The pressure of the liquid is lowest at this point. Casing. The purpose of the pump's casing is to contain the liquid inside the pump during operation. The casing houses all of the pump's internal parts. Outlet. The liquid leaves the pump through the outlet. This side of the pump is also called the discharge side. The pressure of the liquid is highest at this point. Now, take a moment to complete basic pump categories. Inside the pump, there's a component that physically moves the liquid through the pump. The type of component that's used determines the type of pump. Basically, pumps can be grouped into two general categories: positive displacement pumps and centrifugal pumps. Positive displacement pumps. A positive displacement pump uses a piston or some other device to push or positively displace controlled amounts of liquid through the pump. Centrifugal pumps. A centrifugal pump, on the other hand, uses an impeller, which creates a centrifugal force to move the liquid. Centrifugal force is the force that develops when something moves or spins in a circular motion. In a centrifugal pump, this force pushes the liquid away from the center of rotation and out of the pump. Now, take a moment to On most pumps, a shaft is used to transfer power from a driver to the component in the pump that moves the liquid. The point where this shaft enters the pump's casing must be sealed to keep the process liquid inside the pump. The area between the shaft and the casing is commonly sealed using either packing or a mechanical seal. Packing. The simplest way to seal between the shaft and the casing is to use packing. Packing is a flexible material that fits into the space between the shaft and the casing. When packing is used, a small amount of process liquid is allowed to leak through. The leak-off acts as a cooling mechanism to remove heat from the packing. If too much leak-off is allowed, the efficiency of the pump may be affected. On the other hand, if too little leak-off is allowed, the packing will overheat, dry out, and possibly burn. The packing on a pump is held in place by a packing gland. The packing gland is bolted to the pump's casing, and it can be adjusted to maintain the proper amount of leak-off. Mechanical seals. Another way to seal between a pump's shaft and its casing is to use a mechanical seal. Mechanical seals do the same basic job as packing, but they provide a more complete seal. A mechanical seal has two elements, a stationary element and a rotating element. Each element has a seal ring. The seal rings mate together to form a nearly perfect seal that has virtually no leak-off. Seal lubrication. To prevent the seal rings from drying out, overheating, and becoming damaged,
Identifying
some
pumps.
type of lubricant
All
must be
pumps have the
supplied
same
to the seal
basic
rings.
function.
To move
In some
liquids
applications,
the liquid being pumped is used as the lubricant. However, if the liquid being pumped contains abrasives or would be hazardous if the seal failed, an external source of clean liquid may be used to lubricate the seal rings. Auxiliary equipment. All types of pumps have auxiliary equipment associated with them. These pieces of equipment have specific functions that are necessary for proper pump operation. Four common types of auxiliary equipment are drivers, couplings, strainers, and lubricating systems. Drivers. The purpose of a driver is to supply the power needed to produce the pumping action. Electric motors are the most frequently used type of driver. In this example, an electric motor drives the impeller inside a centrifugal pump. This driver is a steam turbine. Steam turbines are often used in applications where a steam supply is readily available. Couplings. Another piece of auxiliary equipment is a coupling. A coupling is a device that connects the driver's shaft to the pump shaft. Couplings can be divided into two categories, fixed couplings and variable couplings. When a fixed coupling is used, the speed of the pump is fixed by the speed of the driver. To change the speed of the pump, the speed of the driver has to be changed. On the other hand, when a variable coupling is used, the speed of the pump can be changed without changing the speed of the driver. Strainers. A strainer is another type of auxiliary equipment that's often used with pumps. Strainers are used to trap and remove solids from the process liquid before they can enter the pump and cause damage. Lubricating systems. Another type of auxiliary equipment that many pumps rely on is a lubricating system. A lubricating system is used to lubricate a pump's bearings. Bearings are used to support and align the moving parts of a pump. If the bearings are not sufficiently lubricated, they will overheat and they could be damaged.
Now, take a moment to complete.
Type of lubricating system. There are two general types of lubricating systems, passive feed systems and forced feed systems. Passive feed systems. Passive feed systems use delivery methods such as gravity to deliver lubricants to the bearings. This constant level oiler is one type of passive feed lubricating system. The oiler has a small reservoir of oil that drains by gravity into the bearing. Another passive feed system is used on bearings that use grease as a lubricant. Grease is supplied at periodic intervals throughout a grease fitting on the bearing's housing. Forced feed systems. Some pumps need a greater supply of lubricant to the bearings, so they use a forced feed system. For example, this system pumps oil through these lines to constantly supply oil to the bearings. The system also has devices that filter contaminants from the oil. Reciprocating piston pumps. One type of positive displacement pump that is commonly found in industrial facilities is a reciprocating pump. Reciprocating pumps use a back and forth motion to move process fluid. A piston pump is one kind of reciprocating pump. Components. This is a simplified illustration of one type of reciprocating pump. It's made up of a cylinder, which is located inside the casing, and a piston, which is attached to a connecting rod. The pump also has two valves, a suction valve and a discharge valve. Operation. During operation, when the piston moves back on the suction stroke, the pressure inside the cylinder is reduced. The reduced pressure closes the discharge valve, opens the suction valve, and draws a specific amount of liquid into the cylinder. When the piston moves forward on the discharge stroke, it exerts a force on the liquid in the cylinder that increases the pressure. The increased pressure shuts the suction valve, opens the discharge valve, and pushes the liquid out of the pump. After the liquid is displaced, the piston moves back and more liquid is drawn into the pump to begin the cycle all over again. Reciprocating diaphragm pumps. Instead of a piston, some pumps use other devices to displace liquid. The pump shown here is a diaphragm pump. It uses a flexible diaphragm to create the reciprocating motion that displaces the liquid. Components. The flexible diaphragm is installed across the pumping area or cavity. The diaphragm is attached to a connecting rod, which on this pump is connected to a motor-driven device called an eccentric. The eccentric and the connecting rod convert the rotation of the motor to a reciprocating motion. The suction and discharge valves are located underneath the pump cavity. Operation. At the start of the suction stroke, the connecting rod is in its lowest position, and the diaphragm is flexed to its maximum downward position. As the eccentric rotates, it pulls the diaphragm upward. This creates a reduced pressure below the diaphragm, which closes the discharge valve, opens the suction valve, and draws a specific amount of liquid into the pump. As the eccentric continues to rotate, it forces the diaphragm downward to start the discharge stroke. The downward motion of the diaphragm exerts a force on the liquid in the cavity, which increases the pressure. The increased pressure closes the suction valve, opens the discharge valve, and pushes the liquid out of the pump. Application. An important characteristic of all diaphragm pumps is that they have no mechanical seals of packing. For that reason, they're often used in applications where little or no rotary gear pumps. Another type of pump positive displacement pump is a rotary pump. A rotary pump displaces liquid with a rotary or rotating motion. Many different types of rotating mechanisms can be used to move liquids, such as screws or gears. Components. This is an illustration of one type of rotary pump, a gear pump. This pump consists of a casing with a suction port and a discharge port. Inside the casing are two gears. One gear is rotated by the pump's driver. This gear is often referred to as a driver or driving gear. The other gear moves because its teeth are meshed with the teeth of the driver gear. This gear is referred to as an idler gear. Operation. During operation, liquid enters the pump through the suction port. As the gears turn and unmesh, liquid is trapped in the spaces between the casing and the gear teeth and moved along the casing in the gear teeth and moved along the casing until it reaches the discharge port where it's forced out of the pump. On this type of pump, each space between the gear teeth positively displaces a given amount of liquid. Soon, each revolution that the gears make, a specific amount of liquid is pumped. Rotary screw pumps. Another type of rotary pump is a screw pump. Components. This pump uses screws to create the rotary motion that displaces the liquid. This pump consists of a casing with a suction port and a discharge port. Inside the casing are two screws. One screw is the driver and the other is an idler screw. Operation. During operation, liquid enters the pump through the suction port and is directed to the suction end of the screws. As the screws turn, liquid is trapped in the spaces between the casing and the threads on the screws and moved along the casing until it reaches the discharge port, where it's forced out of the pump. On this type of pump, each space between the screws and the cases positively displaces a given amount of liquid. Each revolution that the screws make, a specific amount of liquid is pumped. Centrifugal pumps overview. Like all pumps, centrifugal pumps are used to move liquids. To move the liquid, they use centrifugal force. Because of their design, centrifugal pumps can be used to pump liquids at high flow rates. Components. Here's a simplified illustration of a typical centrifugal pump. Inside the pump is a circular component called an impeller. The impeller has a series of curved vanes that extend out from its center. The pump's casing is designed so that the area around the impeller creates a gradually widening spiral channel. This widening channel is known as the volute. Since this pump has only one impeller and one volute, it is referred to as a single-stage pump. Operation. During operation, the pump's driver rotates the impeller, creating centrifugal force that throws the liquid outward into the volute. The outward movement of the liquid causes two things to happen. First, it creates a reduced pressure area at the center, or suction eye, of the impeller. This area of lower pressure draws more liquid into the pump and provides a constant flow of liquid. Second, it causes the liquid to gain speed. This happens because the liquid is forced to the outside of the impeller. The outside edge of the impeller rotates faster since it covers a greater distance than the center. Since the liquid is forced to the outside edge, it is forced to keep up with the rotating impeller. As the liquid flows through the volute, it spreads out to fill the increasing area of the volute. This expansion causes the liquid to slow down and its pressure to increase. The increased pressure moves the liquid through the discharge of the pump and then on through the piping systems of the process. Multi-stage centrifugal pumps. All centrifugal pumps work by creating a centrifugal force. This force increases the liquid's speed, and the speed is converted into pressure. In applications where large increases in pressure are needed, a multi-stage centrifugal pump is often used. Design. A multi-stage centrifugal pump contains two or more impellers in a single casing. Here's a simplified illustration of a multi-stage centrifugal pump. Since it has 3 impellers, it is a 3-stage pump. Each stage of the pump has its own volute. In the volute, the fast-moving liquid slows down and its pressure increases. Each of the first 2 volutes discharges into the suction eye of the stage that follows it. The third stage volute discharges into the pump's outlet. Operation. Thrust. As the liquid passes through the pump, its pressure increases and it exerts a push on the impellers in each stage. This push or thrust is caused by the difference in pressure between the suction eye and the volute. The thrust is directed toward the suction eye. Operation. Offsetting thrust. In order for the pump to operate properly, the thrust must be offset. On some pumps, a bearing is used to offset the thrust. In other pumps, a device known as a balance piston or balance drum is used. The pump in this illustration has a balance piston. Some of the fluid leaving the pump flows along the shaft and exerts pressure against the balance piston. That pressure tends to force the pump's shaft away from the suction eyes and reduces the total thrust. Any fluid that passes by the balance piston is returned to the suction side of the first stage. Summary and implications. The proper flow of fluids is essential to efficient plant operation. Liquids are moved through plant piping systems by pumps, and operators are responsible for making sure that these pumps are operating correctly. This course examined some of the fundamental aspects of pumps, including the design and operation of 2 basic types of pumps, positive displacement pumps and centrifugal pumps. The topics in this course explored how pumps can be identified, basic components of a pump, the functions of various types of pump auxiliary equipment and systems, the general operation of reciprocating pumps and rotary pumps, and the general operation of single-stage and multi-stage centrifugal pumps. Identifying pumps. All pumps have the same basic function, to move liquids through piping systems to where they're needed in the plant. However, different types of pumps are used in plants, and they're identified in different ways. Liquid. One way that a pump can be identified is by the liquid that it pumps. For example, this pump supplies feed water to a boiler, so it can be called a feed water pump or a